But there are challenges. There are technical challenges in that. Let's see how these two constituents travel across this structure. The access to the object is obtained at the ADA level. Then it's being passed down to the very bottom, to this notification engine in C++, and at the time of actual notification, it's being delivered again to the ADA level, where it's being used to reconstruct the dispatching code. Okay? Which means, really, that the object pointer is being obtained at the ADA level and used at the ADA level, as long as the C++ layers do nothing but to the value of this pointer, it's safe. Which means that the pointer is really only temporarily stored at the C++ level, but is being used at the ADA level. This is a little bit different with the action pointer. The action pointer is being obtained at the ADA level. It's actually the access value to the trampoline procedure, which has appropriate calling convention using pragma convention. That access value is being passed down the stack, but at the time of actual notification is being delivered here, because this translation layer has to pass the execution, the control flow higher. Okay? And this is challenging. This is challenging because the pointer is obtained in one language domain, but is being used in another language domain. This is properly handled by ADA. It's properly handled because the language specification provides provisions for this. There is pragma convention, there is exact description of what happens when access value to the subprogram is being passed to another language, but there is nothing really clear at the C++ level. That access value is delivered to C++ as a very low-level row pointer value, the void start stuff. That pointer has to be converted to the function pointer so that it can be used to call higher layers. And of course, the conversion is where problems can occur. The C++ type system has a pretty bad reputation in the ADA community. I know that. But believe me, it's very difficult to convert a row pointer to a function pointer. It's so difficult because the compiler always finds some reason to complain about that. And the only way that I found, which works and compiles cleanly, is with the use of unions. Union is probably the most brute-force way to convert anything in C and C++. If you read the source code and you ever wonder what the union is doing there, it's trying very hard to convert the pointer that was passed from ADA layer to something that is a callable entity. Okay? You might argue that this opens opportunity for portability problems. But let's be frank, we cannot create an effective language binding based only on language standards. You cannot take a random ADA compiler, even fully standard compliant, and the random C++ compiler, even fully standard compliant, and expect them to work, because there is just too much implementation liberty in both languages. What you need is a pair of friendly compilers which will understand at least the fundamental concepts in the same way. And the fundamental concept here is the addressing. I have used GNAT and G++ for this project, and these are not just friendly compilers. They actually belong to the same compiler toolchain, to the same compiler family, and that's why it works. And this can make up for the missing specification in the language standards. Okay? But as I've said, the problem is really on C++ level, because it's not really clear what does it mean to convert a row pointer to a function pointer. With objects, it's specified, but with functions, it's not that clear. Let's see what are the architectural consequences of this. There are basically two big layers. The only dependency that had to be introduced is between ADA and C++, that direction. I didn't have to modify anything at the C++ level. This reflects a common practice when Ada programmers wrap existing C++ libraries. If they can do that without modifying the C++ library, it's very good for maintainability of the whole. But I can also imagine, thanks to this very loose coupling, I can also imagine a different architectural combinations here. For example, we can think about replacing the C++ component with a different implementation. I don't know, maybe Ada, maybe Fortran, I don't know. As long as we can ensure that this channel is using the same conventions, it should all work. I can also imagine additional top-level components, not necessarily Ada, maybe something else. So this loose coupling is really very, very flexible. And the timer says that we still have some time for answers.
We need questions first. We need questions first.
Yes.
To clarify a function call, you have three scenarios. The first one is when there's a piece of data, a copy of data that you want to operate on, okay? And the second situation is there's a reference. You're using type of call by reference, or you're. Can you go back a few slides?
Absolutely. I think that is this enough?
The second layer scenario, the Ada translation layer. This is when you're calling to a pointer to a reference to a data item. Right?
Mm-hmm.
So then the third scenario is when there's a pointer to a function. That's the one that needs the union hack.
Yes, yes. Yeah. The union hack is really used for this case because in the case of the object pointer, it's being obtained in Ada, and when it comes back, it's being used in Ada. So there's nothing to convert as long as you get the bit representation correctly. But in the case of the action pointer, which here is the access value to the procedure in Ada, that has to be converted somehow because it comes down to C++ as a void pointer, the void start stuff. It has to be somehow converted to a callable entity because you cannot call void pointer. You can call a function, and the question is how to make a function out of a void pointer. Okay? And this is the tricky part, and the union was used only for this.
This work is part of the YAML 4 project.
That's right. That's right.
Is there a book on that subject?
Yes, there is. It's a tricky question because you all know that the book is in the corridor. There is a book which is really just a printed documentation for the library. Yes, it's this. It's the documentation, the user documentation for the whole library, which describes how this communication infrastructure can be used effectively.
Any more questions?